So, dear students, today we are discussing about the need of modulation. What is the basic need of modulation? In our previous lecture, we have discussed about the various types of modulation techniques, in which we have discussed about amplitude modulation, that is known as AM. This was one of the modulation technique, amplitude modulation. Second one was frequency modulation. And third one was phase modulation. These three types of modulation techniques we have already discussed. And today one of the important topic, that is what is the basic need of modulation. In basic need of modulation, first of all we will discuss about need of modulation. One of the basic need of modulation is reduction in antenna height. So when we are going for modulation, or when without modulation we are transmitting a signal without modulation, so what about the requirement of the antenna? यानी हमें एंटीना कितनी लगेगी? कभी कभी अगर हम बेस बैंड सिग्नल, we have discussed about what is a base band signal. Base band signal is that type of signal which is without modulation. यानी बेस बैंड सिग्नल वो एक सिग्नल है जो विदाउट मॉड्यूलेशन होती है. हम पहले इस रिडक्शन इन एंटीना हाइट में क्या करेंगे, हम पहले एक ट्रांसमिशन करेंगे एक बेस बैंड सिग्नल का जो विदाउट मॉड्यूलेशन होगी, और दूसरी सिग्नल का आफ्टर मॉड्यूलेशन. इसके लिए हमें कितनी एंटीना की जरूरत लगेगी, हाउ मच इज द रिक्वायरमेंट ऑफ द एंटीना when we send the signal, baseband signal, that means without modulation. And what about after modulation? Is there any change in antenna height or not? So first of all, I will take a baseband signal. Let us take a baseband signal of 10 kilohertz. That is without, that is baseband signal. Let a baseband signal of 10 kilohertz is transmitting. We have to transmit a baseband signal of 10 kilohertz. So we will find out how much is the requirement of the antenna for the reception or for the transmission. Okay. So I have already told you, for the transmission of baseband signal, the antenna height should be, multiplied by lambda upon 4. This is where this lambda upon 4 comes. We have already discussed it. Lambda upon 4, where it already we have discussed. We have made a formula for lambda upon 4, right? Lambda is what? Lambda is wavelength. Of the modulating signal. Okay. So those who will ask me a question where actually this lambda upon 4 comes, so he will assess my last lecture in which we have discussed about lambda upon 4. Why the antenna height should be multiplied by lambda upon 4. Okay. In our previous lecture we have already discussed it. Okay, good. So wavelength. Lambda is wavelength and it should be divided by 4, lambda by 4, right? Okay, now the second important thing is, for the transmission of this baseband signal of 10 kilohertz, we will find out that for the baseband signal of 10 kilohertz what about the antenna height? So antenna height should be multiplied by lambda by 4. So h is equal to lambda upon 4. This is the basic formula for how can we find out the height of the antenna. Okay. So in our previous chapters in optics and wave optics and ray optics, we have discussed about this lambda is equal to c upon f. What is c? C is nothing but it is the velocity of light. Velocity of light, and that velocity of light should be equivalent to 3 into 10 to the power 8 meter per second. And what about this frequency? This is frequency, and this is frequency of modulating signal. Frequency of modulating signal, right? Okay. If lambda is equal to c upon f, then therefore h is equal to lambda. Lambda की जगह हम क्या करेंगे? Put c upon f. So it will become h is equal to c upon 4 of f. Okay. So we will put the values c upon 4f. F is what? F is our modulating frequency, and that modulating frequency is how much? That is here, that is 10 kilohertz. What we are doing? We are doing how much requirement of the antenna. We require an antenna if we transmit a signal of 10 kilohertz before modulation, and after we will modulate this 10 kilohertz with a high frequency carrier, and after that we will find out the antenna height. Okay, so it will become how much? C, this is equivalent to 3 into 10 to the power 8 divided by 4 into 10 kilohertz, 10 into 10 to the power 3 hertz. Okay, this will become 3 into 10 to the power 8, 3 into 10 to the power 8, 10 to the power 4. So it will become multiplied by 10 to the power minus 4 divided by 4, and it will become 10 to the power 8, 10 to the power minus, in case of multiplication bases are same powers are added, so it will become 3 into 10 to the power 4 divided by 4, right? 3 into 10 to the power 4 divided by 4, so it will become 3, 0, 0, 0, 0 and 0 divided by 4, right? So it will become 4, 7, 5, 0, 0 meters. So you will see the antenna height h. We'll find h is equal to 7,500 meters, and this h is equivalent to 7.5 kilometers. Just to see the amazing thing here, in order to transmit a radio signal of 10 kilohertz, we need the height of the antenna, that is 7.5 kilometers. Can you imagine how much big is this 7.5 kilometer antenna? Can we imagine? Okay, can we install? No. But practically, अगर हम देखें तो practically the height h is equal to 7.5 kilometers is impossible to design. So at the last we conclude that whenever we have to transmit a baseband signal without modulation for 10 kilohertz, we need an antenna of 7.5 kilometers. Now we will see if we have to transmit this 10 kilohertz. First of all, we will modulate this, and after that we will find out how much is the requirement of the antenna after modulation. We will see this after modulation, what is the requirement of the antenna, how much we require. Just see. So without modulation, h is equal to 7.5 kilometers. Remember it. H is equal to 7.5 kilometers. Now what we have to do? We have to go for modulation. So after modulation, 10 kilohertz, after modulation, the 10 kilohertz signal will become, suppose after modulation, after amplitude modulation, it will become 1 megahertz. So here you will remember that what we are doing in modulation. Modulation में हम क्या करते थे, हम एक लो फ्रीक्वेंसी सिग्नल को उसके एक हाई फ्रीक्वेंसी कैरियर के ऊपर सुपर इम्पोज करते थे. और आफ्टर मॉड्यूलेशन, अगर आपको याद होगा, मैंने आपको बताया था कि ये जो हमारी सिग्नल बनती है, ये हमें इस तरह की एक सिग्नल बनती है और इसके अंदर जो ये वाली चीज होती है, दिस इज द कैरियर. So we are doing nothing in modulation. Simply we for 10 kilohertz we convert this 10 kilohertz. After modulation, it will 10 kilohertz, it will become 1 megahertz. After modulation, we have done the modulation for 10 kilohertz, and 10 kilohertz signal after modulation become 1 megahertz. Now we will find out the antenna height for 1 megahertz signal. Now the antenna height after modulation, the antenna height will become, after modulation the antenna height will become, as the formula, h is equal to lambda upon 4, and this formula will become h lambda by c upon 4f. This is our formula for antenna height, c upon 4f. So h is equal to c upon 4 of f, and c is equal to what? 3 into 10 to the power 8, and 4 is as it is, 4 multiplied by frequency. And what about the frequency? So frequency is 1 megahertz. So 1 into 10 to the power 6 for megahertz, right? 10 to the power 6 for megahertz. Everybody known to this? सबको पता है? Okay, good. इधर ध्यान दीजिए. तो ये क्या बनेगा? ये बनेगा 3 into 10 to the power 8. 10 to the power 6 ऊपर हो जाएगा. 10 to the power minus 6 divided by 4. So it will become 3 into 10 to the power 2. Clear? 8 minus 6 2 divided by 4. So it will become 300 divided by 4, and it will become 75. It will become 75 meters. And 75 meters, the antenna height should be 75 meters, and you will see before modulation, the antenna height h is equal to 7.5 kilometers. This is the big thing that which we have to remember, that for without modulation the h is equal to 7.5 kilometers, and after modulation this will become 75 meters. But 75 meter antenna is practically possible to design. यानी ये हम बना सकते हैं, ये प्रैक्टिकली पॉसिबल है. सो इसीलिए इफ यू सी इन अवर मोबाइल फोन्स, इन टुडेज मोबाइल फोन्स, अगर आप आज से 4 साल 5 साल से पहले की बात करेंगे तो हमारे मोबाइल फोन्स में एंटीना एक बाहर से इतनी सी एंटीना आती थी. ओके, सो वो एंटीना आजकल के मोबाइल में नहीं आती है. सो आजकल के मोबाइल में हम क्या करते हैं, बेसिकली वी आर डूइंग फॉर द मॉड्यूलेशन टेक्निक. एंड आजकल जो हमारे मोबाइल काम करते हैं 900 megahertz, 1800 megahertz, and if you go for 900 megahertz, if you go for 1800 megahertz. So here 1 megahertz can be replaced by 1800 megahertz. 1800 megahertz. So if we put here 1800 megahertz, so it will become 0.0 something like that. So you will see this is the reduction in antenna height. So in order to reduce the antenna, simply what we have to do, we have go for modulation and we will put a high frequency carrier. हम एक high frequency carrier put करेंगे and after that उसकी modulation करेंगे एक high frequency carrier के बाद एक modulated signal बनेगी megahertz में. तो उसके बाद में जब हमने check किया इस सारे की calculation करके हमने ये find out result कर दिया कि in order to reduce the antenna height, simply we will go for modulation, and this is the need of modulation, and I have simply need of modulation is reduction in antenna height. Reduction in antenna height is only possible because of modulation, right? This is the first need, that is reduction in antenna height, and that is by the use of modulation. Okay, now the second thing which is very important, that is our topic is what? Our topic is need of modulation. And the second very important thing which we have to remember, which we have to discuss, that is by the use of modulation technique, we can avoid mixing of signals. So the next important thing, second thing is avoid mixing of signals. Avoid mixing of signals. This is very important. Avoid mixing of signals. Let us see what actually this means. Avoid mixing of signals. You will see if we have to transmit a radio signal. So there are so many users who want to transmit their radio signal. Okay, there are so many users who want to transmit their radio signal without modulation. So everybody, suppose we have a signal 1, and signal 1 is the one person who want to transmit his message in an audio frequency range, and you know the audio frequency range should be equivalent to, that is 0 to 20 kilohertz. इसका ये मतलब है कि अगर हमारे पास एक यूजर है जिसके पास सिग्नल 1 है और वो इसको भेजना चाहता है विदाउट मॉड्यूलेशन, सिग्नल 1, and the range where everybody has a range that is equivalent to 0 to 20 kilohertz. 0 to 20 kilohertz में ऑलमोस्ट सभी बात करते हैं. तो अगर मैंने अपनी एक मैसेज मुझे किसी पर्टिकुलर आदमी को भेजनी है, किसी पर्सन को देनी है, तो इसका ये मतलब है कि उसका रेंज जो होगा that is between 0 to 20 kilohertz, right? So the second person is same. If I will talk about signals 2, that is for second person, he also has a signal in the frequency domain that is 0 to 20 kilohertz. This is another person who want to send hello, and this is the person who want to send hello in the same frequency range between 0 to 20 kilohertz. Now the third person who also wants to send the signal in the same frequency range, suppose same frequency range that is between 0 to 20 kilohertz. Now see here what actually happens. If we have a communication channel and there are 3 users who want to transmit their message in the same frequency channel, and you will see this is 0 to 20 kilohertz, this is 0 to 20 kilohertz, this is 0 to 20 kilohertz, and all the signals in the communication channel will mix up if we will send these signals without modulation. Without modulation, तो सेम चीज मैं आपको बोलता हूं, अगर हम यहाँ पर 3 बंदे हैं, तीनों एक ही सड़क के थ्रू जाना चाहते हैं, तो कैसे रिसीवर को पता लगेगा कि मेरी मैसेज कहाँ है? सेम है, यानी हमारी शक्ल भी एक है, एवरीथिंग इज सेम, कॉमन. सो हाउ कैन वी रिकॉग्नाइज, हाउ कैन वी डिस्टिंग्विश अमंग द सिग्नल्स? So this is the frequency range 0 to 20, 0 to 20, 0. If we will send the same communication channel, all these signals, so they will mix up. Now, in order to avoid this mixing, let us see here. In order to avoid this mixing, we are going for a modulation. So in modulation technique, what actually we are doing? We are giving a separate carrier. We are giving to separate carrier to this signal. Suppose we have provided this carrier for this signal. We have provided a carrier of 300, 100 kilohertz. What is this 100 kilohertz? This 100 kilohertz is the carrier, and you know where we are providing the carrier. Carrier providing means we are doing what? We are doing modulation. Carrier providing means we are doing modulation. So for this signal, we are providing a carrier of 100 kilohertz, and you know our message will superimpose on the carrier. Our message will superimpose on the carrier, or it will be reduction in the carrier. So here it will be 100 plus 20, then it will become 120, and it will become 80. Either it will be minus, कैरियर को माइनस हो जाएगा 20, या कैरियर को प्लस हो जाएगा 20. तो ये हमारे पास एक सिग्नल है जो हमने कम्युनिकेशन चैनल के थ्रू ट्रांसमिट की, जिसको हमने कैरियर दिया 100 किलोहर्ट्ज. नाउ वी विल गो फॉर दिस. नाउ वी विल प्रोवाइड द सेपरेट कैरियर, one more carrier to this signal. Suppose we will provide the carrier to this signal that is equivalent to 200 kilohertz. For this we go for 100 kilohertz. For this signal we have provided 200 kilohertz carrier. 200 kilohertz means that it will become 220, and here it will become 220, and it will become 180, and it will become 120. So 200 plus 20, that is 220. 200 minus 20, that will become 180. And suppose this is this signal, we have transmitted it in the communication channel, and here it is. Okay, for the first signal we will do the same modulation technique, and we will go for the carrier that is equivalent to this carrier. Suppose this is 300 kilohertz. So if the carrier here is 300 kilohertz, so if the signal will become, so this signal will become, it will become 300 kilohertz, it will become 320 and 280. Okay, 280 and 320, this is this carrier. This is 300 carrier. Now what I am going to discuss about, this is our communication channel in which we have sent the 3 signals. Just see, if we will send these signals in a communication channel without modulation, so without modulation, every communication channel has, every frequency signal has a frequency range 0 to 20, 0 to 20, 0 to 20. So if we will send as it is, if we send these in a communication channel, there is a mixing. There is a mixing. So the information will get mixed up, and there is an interference. So in order to provide high separated carrier, we avoid the mixing of signals. So in modulation technique, when we are providing a separate carrier, to the same frequency range, they will not get mixing in the common communication channel. ये तो सिंपल सी बात है. अगर हम एक सड़क के ऊपर जाएंगे, वहां से हम ऑटो को रखेंगे, हम बस को रखेंगे, हम सोमो को रखेंगे, और सब में सेम इंफॉर्मेशन है, लेकिन बस और सोमो और ऑटो एक दूसरे से मिक्सअप नहीं हो जाएंगे, चाहे वो एक ही कम्युनिकेशन चैनल के थ्रू पास हो जाए. So this is the second important thing, avoid mixing of signal, and this come into the need of modulation. Third is long distance communication. Long distance communication. Long distance communication means if we will send a signal without modulation, that is a low frequency signal. So low frequency signal means it has low energy. Low energy means it has low power. So low power signal cannot be transmitted to a longer distance. So in order to overcome this problem, low frequency, low energy, low power, we will go for modulation. So modulation provides a high frequency carrier, and high frequency means high energy. High energy means high power. Okay? Long reception, this is the what is the basic need of modulation in our communication system. Okay? Thank you for today's class. Inshallah we will meet soon.